Sai Ram. Dear learners, welcome to Shri Sathya Sai Lok Seva Gurukulam online classes. We are doing Senior Secondary Mathematics chapter Permutations and Combination. This is part 7. In part 7, we'll be doing permutations with some conditions. Let's first do a quick recapitulation of what has been done in this chapter till now. Here we learned to find the number of ways in which a given number of objects can be arranged. That is the basic definition of permutation: arrangement of objects in a particular way. Then we discussed fundamental principle of counting. If you can recall, if there are n events, and out of these n events, if m1 events or the first event can occur in m1 ways, second event can occur in m2 ways after the first event has taken place, third event can take place in m3 ways after the second event has taken place. Then the total number of ways in which the events can take place is given by m1 multiplied by m2 multiplied by m3, so on, and last one would be mn. These many ways, and before mn it would be mn minus 1. Then we also learnt what is the meaning of factorial n. Factorial n is also written like this, or it is written in this way. So what is factorial n? Factorial n is n multiplied by n minus 1 multiplied by n minus 2, so on up to 1. This is the meaning of factorial n. After this, we discuss permutations of R objects out of n objects. So basically, we learnt what is NPR. We had to arrange R objects out of n objects. So what is NPR? NPR is factorial n upon factorial n minus r. In this session today, we will be looking at permutations under some conditions, and we will directly take up the problems to understand these questions. I am taking up exercise 11.5. Question number 1 is Mr. Gupta with Miss Gupta and their 4 children are traveling by train. So how many people are there? First one is Mr. Gupta. Second one is Miss Gupta, and there are first one is Mr. Gupta, second one is Miss Gupta, 2 and plus 4 children, so total 6 are there. 2 lower berths, 2 middle berths and 2 upper berths have been allocated. The berths be shared by the family. So let us look at it. Total how many people? We have got 6 people and we have got 6 berths. Condition. First one is Mr. Gupta. He will occupy only one birth, but how many options does he have? What are the various choices available to him? There are two choices. Either he can take the birth on the right hand side, or he can take the lower birth on the left hand side. So in how many ways Mr. Gupta can take the seats? Factorial 2 ways. What is the value of factorial 2? Value of factorial 2 is 2 into 1, that is 2. Same way with Miss Gupta. She wants the uppermost berths. So how many uppermost berths are there? Only 2. So in how many ways can Miss Gupta occupy the berths? Same way, the way we had done for Mr. Gupta, Miss Gupta can either take the uppermost berth on the right side or the uppermost berth on the left side. So in how many ways can she take it? 2 factorial. Now we have 4 children. And how many berths are there? 1 berth has been occupied by Mr. Gupta. Second berth has been occupied by Miss Gupta. So 2 berths are gone. Total were 6. How many are left? 4 are left, and 4 people will occupy them. In how many ways can 4 people occupy 4 berths? That is quite simple. Factorial 4. So we need to find in how many ways can the berths be shared by the family. So required number of ways, or you can write down the number of ways in which the berths can be shared by the family is equal to factorial 2 multiplied by factorial 2 multiplied by factorial 4. Find the answer. Factorial 2 is 2. Again I write down 2. And what is factorial 4? 4 into 3 into 2 into 1. 4 3s are 12. 12 2s are 24. And what answer do you get when you multiply 4 by 24? We get 96. So 96 is the answer, or in 96 ways the berths can be shared by the family under the given conditions. Now let us look at next question. Consider the word unbiased. How many words can be formed with the letters of the word in which no 2 vowels are together? Total number of letters in the word unbiased is how many? 1, 2, 3, 4, 5, 6, 7, 8. So we have got 8 letters in the word unbiased. And how many vowels are there? U is a vowel, I is a vowel, A is a vowel, and E is a vowel. So we have got 4 vowels. If you leave aside the vowels, we are left with consonants. How many consonants are there? We have 4 consonants. So in the word unbiased, we have 4 vowels and 4 consonants. So the condition that is given is that no 2 vowels are together. So if vowels are not together, let's see how can we arrange them. Let me see. Let me make it here. We have consonants, 4 consonants. Let's place 4 consonants like this. If we don't want any vowel, or if we don't want 2 vowels together, so there should be one consonant between two vowels. So vowels can take up these places. Vowel can come before consonant and vowel can come after consonant. So let's see how to arrange the consonants first. So we have fixed up the four consonants 1, 2, 3 and 4. So four consonants can be arranged in how many ways? There are four consonants. They can be arranged in factorial 4 ways. Now let us look at the number of positions available for the vowels. This is first position, second, third, fourth, fifth. So there are 5 places where vowels can be put. But how many vowels do we have? We have only 4 vowels. 4 vowels we have to arrange at 5 places. So let us see in how many ways can we arrange the vowels. That means what we are looking at? We are looking at permutations of 5 objects taken 4 at a time. There are 5 places and 4 vowels are there. So it is factorial. It is 5p4. And what is 5p4? 5p4 will be 5 factorial 5 divided by 5 minus 4. So it is factorial 5 divided by factorial 1 and this would be factorial 5. So required number of ways, that means how many words, the number of words that can be formed with the letters of the word unbiased in which no 2 vowels are together will be factorial 4 multiplied by factorial 5. So what answer do we get? Factorial 4 is 4 3s are 12. 12 into 2 is 24. And factorial 5 is 5 into 4 into 3 into 2 into 1. So that would be 120. Multiply these two, you will get the answer 2880. Let's look at the next question. There are 4 books on mathematics, 5 books on English and 6 books on science. Five books are there. For maths we have 4 books. For maths, we have 4 books. For English, we have 5 books. And for science, we have 6 books. In how many ways can you arrange them so that the books on the same subject are together and they are arranged in the order mathematics, English, science? So this is a sequence. We can't change the sequence. We cannot put English first, maths later. We have to stick to the sequence, that is maths is first, then English, and then science, and all maths books together, all English books together, and all science books together. So sequence is already given to us. So what we are going to do is just see in how many ways can the 4 maths books be arranged. This is quite simple. 4 maths books, they can be arranged in factorial 4 ways. 5 English books, they can be arranged in factorial 5 ways. And 6 science books, they can be arranged in factorial 6 ways. We cannot change the order. So the sequence will remain the same. And what is the total number of ways in which the books can be arranged? It will be factorial 4 into factorial 5 into factorial 6. So this gives us required number of ways is factorial 4 into factorial 5 into factorial 6. Now what is factorial 4? 24. What is factorial 5? 120. And what is factorial 6? 720. You can remember the factorial values for some numbers. It will be very handy and calculation would be easier. Multiply 24 by 120 and the whatever answer you get, multiply that by 720 and see whether you are getting this answer. $20,73,600 ways. Just see, we have only 15 books and these 15 books can be arranged in 20,73,600 ways. Keeping all maths books together, first all the maths books together, and then all the English books together, and then all the science books together. If we were given the option of even changing the sequence, all maths books together, but they can come after English or after science, then the number of permutations would be much, much more, as is given in the next question. Question number 4 is similar to the last question with an additional condition. There are 3 physics books, 4 chemistry books, and 5 botany books. And there are 3 zoology books also. In how many ways can you arrange them so that the books of the same subject are together? You have physics, 3 books. You have chemistry, 4 books. You have botany, 5 books. And you have zoology, 3 books. In how many ways can 3 physics books be arranged? Factorial 3 ways. That is 6 permutations are possible. 4 chemistry books can be arranged in factorial 4 ways. 5 botany books can be arranged in 5 factorial ways. And 3 zoology books can be arranged in factorial 3 ways. But we can keep physics books after chemistry, all the physics books together after chemistry. We can keep all the physics books after botany also. or we can keep all chemistry books before physics, or all chemistry books after botany or zoology. So that means we can now consider physics, all books of physics as one unit, all books of chemistry as second unit, all books of botany as third unit, and all books of zoology as 4 units. Now, what are the number of ways in which these 4 units be arranged? So, 4 units can be arranged in factorial 4 ways. So, required number of ways, factorial 4. 4 units, I said, they can be arranged in factorial 4 ways. That takes care of the various sequences which are possible. Physics, botany, zoology, chemistry, or physics, zoology, botany, chemistry. Any such combination can be there, where we are considering all physics books together, all chemistry books together, all botany books together, and all zoology books together. Now, apart from that, the 3 physics books, they can be arranged in factorial 3 ways. 4 chemistry books can be arranged in 4 factorial ways. 5 botany books can be arranged in factorial 5 ways. And 3 zoology books can be arranged in factorial 3 ways. Now solve it. What is the value of factorial 4? By now you must be knowing it. 24. What is the value of factorial 3? 3 2s are 6. What is the value of factorial 4? Again 24. 4 into 3 into 2 into 1. What is the value of factorial 5? 5 into 4 into 3 into 2 into 1. So that is 120. Factorial 3 is 6. Multiply all of them together and see what is your answer. Please do it. So it comes out 24,88,320. Here also we have got just 15 books. And see, these 15 books can be arranged in 24,88,320 ways. And we are keeping all books of same subject together. Let's look at next question. 4 boys and 3 girls are to be seated in 7 chairs such that no 2 boys are together. And in how many ways can this be done? We'll try to do it in the same way we did that question on consonants and vowels, where it was that no 2 vowels are together. Here it is no 2 boys are together. So total we have how many boys and girls? Total number of people, 4 plus 3, 7. So 7 people are there and 7 chairs are there. So let me try to make the chairs. I'll represent the chair by boxes. One, 2, 3, 4, 5, 6, 7. We have got 7 chairs and we have got 4 boys. So let me put a boy, let me mark the position of the boys. Boys here. Then we have to put a girl in between. So 4 boys, they have been placed at 4 places. And then we'll be having a girl here, and a girl here. So here in the diagram, you can clearly see that no 2 girls are together. So first let's write In how many ways can the 4 boys be arranged? 4 boys can be arranged in, we have got 4 chairs for the boys, so they can be arranged in factorial 4 ways. So you have already fixed their position of where the boys are going to sit. Now if you have fixed this position and you have left one chair vacant in between 2 boys, so that is the chair which should be taken by the girls. So 3 girls, they can be arranged in how many ways? 3 girls are there and 3 chairs are there. Once 4 boys occupy the chairs, we are left with only 3 chairs. So it is factorial 3 ways. So in how many ways can this be done? Required number of ways is equal to factorial 4 multiplied by factorial 3. Now solve this. Factorial 4 is 24. Factorial 3 is 6. Multiply it, you will get 144. Required number of ways in which 4 boys and 3 girls can sit on 7 chairs such that no 2 boys are together is going to be 144. So here in this question, we have fixed the boys position first, and we have ensured that no 2 boys are together. If you look at it here, even this condition that no 2 girls are together, that is also being satisfied. So by marking the positions, we have ensured that no 2 boys are together. Let's look at question number 6. Find the number of permutations of the letters of the word Tendulkar in each of the following cases. Let's first look at this word. You need to count the number of letters in it. We have 1, 2, 3, 4, 5, 6, 7, 8 and 9. We have got 9 letters in the word Tendulkar. So there are total 9 letters. Let's look at part 1. In part 1, the condition is that how many words can we form which begin with T and end with R. We have fixed T and R. You cannot do anything about it. So total 9 letters were there, out of which 2 are fixed. So how many do we have to arrange? 7. Total were 9. Now we have to arrange only 7 letters. And in how many places do we have to arrange 7 letters? We have to arrange 7 letters in 7 positions. So what is the number of ways that we can make this arrangement? 7 letters in 7 places. It will be factorial 7 ways. You can find the value of factorial 7. If you calculate the value of factorial 7, it will come 5040, and I hope you remember that factorial 7 means 7 into 6 into 5 into 4 into 3 into 2 into 1. it is equal to 5040. So what have we found? Here we have found number of letters. We have found number of words starting with T and ending with R. We can just write here required number of ways. So it is understood that we are solving this first one, letters which begin with words which begin with T and end with R. Let us look at the second part. We want all the vowels together. Now how many vowels are there? We need to first identify that. This is one vowel, second vowel, and this is third vowel. So we have vowels. All the three vowels, they are together. And how many consonants are there now? Total 9 letters were there. And we have got 6 consonants. We have to form words using all the 9 letters. But 3 vowels should always be together. So how will it look like? Three vowels together, and apart from this we have got 6 consonants. These 3 vowels which are together, they can come here, they can come here, they can come here, they can take any place, but all the 3 vowels, they will be together. So don't you think so that we can treat them as one unit? And you see how many places do we have? We have 1, 2, 3, 4, 5, 6 and 7. So we have, if we need to simplify it, we can say it that we have to arrange 7 letters at 7 places. So we have to arrange 7 letters at 7 places. We are counting all the 3 vowels together and counting them as one unit. So in how many ways can 7 letters be arranged at 7 places? Factorial 7 ways. Now we kept this unit of vowel as one unit. But there are 3 vowels here, E, U and A. They can be together, but they can change their positions. It could be A, E, U or something else. So that means that 3 vowels, though they will be together, but still their arrangements can be different. So what would be the number of arrangements? 3 vowels can occupy 3 positions. So it will be factorial 3 ways. So this is our required number of ways. And what was the condition? We are looking at the letters of the word Tendulkar, in which there are 3 vowels and all 3 vowels need to be together. So when all 3 vowels need to be together, we'll consider them as one unit. So it is actually, if we look at it, it will be, we have to see 7 letters to be placed at 7 places. So factorial 7, and 3 vowels, they can change their positions in factorial 3 ways. So find this answer. What is factorial 7? We have already found 5040, and factorial 3 is 3 into 2 into 1 is 6. So we get the answer 30,240. So this is the answer. Let's look at the third part of it, last part. Vowels are never together. So again, let's remind ourselves that we have got total 9 letters and vowels are not together. So we have got 3 vowels, and how many consonants do we have? Total are 9 letters, 3 vowels. So how many consonants? 6 consonants are there. So 6 consonants can be arranged in how many ways? 6 consonants can be arranged in factorial 6 ways. Let's try to fix their positions. Consonants, six consonants have been placed and they can be arranged in factorial 6 ways. Question says vowels are never together. So vowels, there has to be a consonant in between 2 vowels. Let's see which places can the vowels take. Vowel can come here, it can come here, it can come here, and in this way I can put it anywhere. Now let us see how many places are available for the vowels. We have only 3 vowels, but how many places are available for the vowels? 1, 2, 3, 4, 5, 6, 7. So what have we arrived at? We have arrived at there are 7 positions for 3 vowels. So what would be the number of arrangements? Number of arrangements would be 7p3. And what is 7p3? Factorial 7 upon factorial 7 minus 3, which is factorial 7 upon factorial 4. Let me solve it here. Factorial 7 upon factorial 4. 7, factorial 7 can be written as 7 into 6 into 5 into factorial 4. And factorial 4 can be written here only. So factorial 4 and factorial 4 gets cancelled. We are left with 7 into 6 into 5. And what is 7 into 6 into 5? 210. So vowels can be arranged in 210 ways. Now let us look at the total number of words that can be formed in which no 2 vowels are together. We have to take factorial 6, because factorial 6 is the number of ways in which the consonants can be arranged. And we have to take this value 7p3, which we have calculated as 210. So what is factorial 6? Factorial 6 is 720, and 7p3 we have already found is 210. So when we multiply 720 by 210, we will get 1,51,200. So this is the total number of words that can be formed from the letters of the word Tendulkar, so that no two vowels are together. With this, we have come to the end of this session. Hope you have understood it. Please practice these questions. That's all for today. Thank you so much. Om Shri Sai Ram.